Oh, welcome back. We're back in the garage. As I said earlier, the sea trial went generally very well. And we got a couple of things to work on before we put it back in the water again. I explained the symptoms of the vibration I was feeling when I turned the drive side to side, and he said it's probably U-joint, and that makes total sense to me. So we're going to change those out. I'm not going to do a video on it, but I can tell you a lot of the videos that I am seeing have to do with big hammers and sockets that you hit with the big hammer. I highly recommend that you use a press, just basically an overgrown C-clamp to push these things out. Those are tiny little needle bearings in there, and I think hitting them with a big hammer is probably a bad idea. So the other issue on the sea trial was the inverter went into derating because it was getting a little too warm. Perfectly good response to a perfectly good problem. So we are going to switch this over to water cooled. So just for reference, what I had initially done was bolted a huge heavy aluminum heatsink to the back of the inverter and put those two fans on it, connected the fans up to the X1 controller. That worked out really well, but I'm not as smart as I thought I was because it's not cooling adequately. So this is how we're going to water cool the inverter. This boat's only going to be in fresh water, so I'm not going to worry about closed cooling. But we have a sea strainer pickup, seacock, a finer sea strainer. We have a pump rated at 3 gallons per minute. And we have the cooling plate that gets bolted to the back of the controller and where the water goes out the side of the boat. Now, a couple of thoughts here. Those are 1/8 inch NPT fittings. In my mind, that's choking off the flow way too much, and I'm going to see if I need to deal with that or not here in a minute. The other issue is, if we go back to the nameplate, this thing draws what? I think it draws 8 amps. Yeah, it draws 8 amps. The fuse that I'm controlling the fans with, I think is rated at 10 amps. So I'm going to add a fairly significant, cheap automotive relay rated at 40 amps. And we'll just use the other little relay as a pilot for that. So like I mentioned, I'm a little concerned about the size of the pipe thread going into the cooling plate. The one on your right is 1/8 inch NPT, and the one on your left is 1/4 inch NPT. And if you go back to your grade school math, we know pi r squared tells us the 1/4 inch NPT has 4 times the area of the 1/8 inch NPT. I tried to look up what that actually means in terms of flow rate, and it got very confusing because there's a lot more variables than just the diameter. But that's really what I'm interested in testing right now. So this is a 3.5 gallon bucket. I'm going to fill it up to 3 gallons. That's the 1/4 inch fitting, and here we go. So here we are with the 1/8 inch NPT fitting. Well, so much for what I know. The bucket was filled up to 3 gallons in 30 seconds exactly in both cases. So that's going to make my life a lot easier in terms of piping this thing. I was going to drill and tap the aluminum plate and mill out the back and yada yada, but I don't have to do that. When your flow is limited at one little point as opposed to over a big long pipe run, the diameter is much less important than you might have thought. So there.